What do you call a destructive dinosaur? Tyrannosaurus Rex. I don't know if that made sense. All right, let's go into it today. Today we are extending calculus, but now we're using essentially exponentials with the base e. Okay, so we have learned how to differentiate all these different things. And so now we're going to learn how to differentiate with, I guess, the letter E. When we have a base. Now, E essentially is, you'd think it's Euler's, but I've been hearing everyone say Euler's. So I'm going to go with that. It's Euler's numbers, an Euler's number. It's essentially 2.7183. It's this kind of number that represents a lot of the exponential growth rates that we see. And it's an irrational number that kind of goes on forever and ever. So I've just shortened it down to the first 4 decimal places. Now, essentially, yeah, it's used a lot in growth or decay type questions, how things grow or decay over time. And what's nice about it is it has its own logarithm, log base e. You'll see it in your calculator as this ln thing. Okay, it's just a fancy way of writing log base e. It stands for natural log. Okay, ln. Now, before we can talk about, I guess, the differential part, I guess we're just going to talk about the graphs and the transformations of the exponential. So hopefully you remember that your exponential graph will somewhat look like this. And then to find the y-intercept, I always let x equal 0. E to the power of 0 should always give you 1. Okay, now, of course, that's your base graph. It also has an asymptote at y equals to 0. And yeah, y-intercept of there. So it'll never touch that y equals 0 line. And the exponential just goes whoop, just like that. So what happens if we make the whole graph negative? How does that transform it? Well, everything that was positive now becomes negative. So it's going to look a little bit like this. And now it's going to become -1. Okay, we still have the asymptote. Asymptote hasn't moved. It's still y equals 0. That's that. Now, what happens if I have e to the minus x? So that means I've now made my x negative. Now, usually my graph would look like this. The way that e to the negative x goes is it's actually going to reflect across this x line, x equals 0. So it actually reflects. It's still going to cut at +1. And if you want to double check, what is e to the power of -0? It's still 1. Okay, and again, we're still going to have this asymptote at y equals 0. Okay, and what happens if I was to -1 to the power? That there's actually a horizontal shift. Okay, which means I'm going to move 1 to the right. So normally I would cut here at 1. There's my original. But I'm actually going to move it over 1 to the right because of my -1. And that there is going to become my new graph. So it's going to look a little bit like, I'll try to do a bit better. It should essentially be the same. I'm just struggling at drawing this. Okay, let's say, and that's not bad, not great. But now I know that that point there is 1, 1, because I've moved this point 1 over to the right. Do I have any more? Looks like that's it. Probably last thing that I'll touch on is what happens if I said +1. That means this whole graph now moves up a step. And so does my asymptote. Instead of y equals 0, it will now be at y equals 1. Okay, so that's just in case if we start transforming things up and down that way. I think that's it. Hopefully that helps. Catch you next lesson. Bye-bye.